you have forgotten since then. So here's where I'm going to take you in today's lesson. The learning targets. First one, describe and compare distributions of quantitative variables for one or two groups. Learning target number 2, compare the distribution for a categorical variable for two groups. So we're going to be dealing with both quantitative and categorical variables in today's lesson. And then the last learning target is use graphs to decide if there's an association between two categorical variables. And I am also in today's lesson going to try and make some connections to stuff that you did way later in the course, dealing with inference, specifically significance tests. So let's go ahead and jump right in. All right, here we go. Now, today's question that we're trying to answer, the context for today's lesson, is about which AP class has a higher GPA. And we've got this classic battle between AP Calculus and what we all know to be superior AP Statistics. So here's what the problem says. A university admissions officer wonders if grade point average differs between AP Calculus and AP Statistics students. To find out, she selects a random sample of 20 AP Calculus and 10 AP Statistics students. Here are the results for the 20 AP Calculus students. And it looks to me like we're given a dot plot of the results, as well as some summary statistics there. Now, here's the first thing that we want to recognize here is the variable that is being measured by this data. And very clearly, the variable that we're measuring here is GPA. GPA is our variable. And the next question I want to consider is whether that is a quantitative or a categorical variable. Well, because a student's answer to this question is a number, that's a good hint to us that this is in fact a quantitative variable. Another way of thinking of that is a variable where it actually makes sense to calculate an average or a mean. And certainly we could calculate an average GPA or a mean GPA. So we know for sure that the variable that we're measuring here is a quantitative variable. So everything that we do on this page is going to be dealing with an analysis of quantitative data. All right, so let's jump right into question number 1 here, which says describe the shape of the distribution. And we have a couple of choices when it comes to shape. I think the first thing to always address is whether it appears that the distribution is symmetric or skewed one way. And certainly this is not a symmetric distribution, and it does have a skew to it. In fact, it looks like it's definitely skewed a little bit to the left there. Okay, so I'm gonna say that this is skewed left. And I usually like to give a word out in front of that, like slightly, moderately. This is a fairly strongly skewed left distribution. So I'm gonna say strongly skewed left. Now here's where I'm going to pause. I'm actually going to give you a very important AP exam tip. And that is when you're answering free response questions, you want to do your best to always include the context of the question. And so if you just looked at our answer right now, strongly skewed left, it doesn't say anything about the context of the problem here. And so I'm going to add in something here. I'm going to say the distribution of GPA is strongly skewed to the left. So now here very clearly I've included the context of the problem. Just make a little note here. What I'm doing is I'm including context. And on the AP exam, in a particular question in one FRQ, if you've established context once, you don't have to continue to say it over and over and over again. So it's very good to do that right off the bat. So question number 1, we've taken care of the context here. All right, question number 2, is the mean or the median a better measure of center of the distribution? Well, the answer to this question depends on the shape of the distribution, and we know that this is a strongly skewed distribution. So the issue with a skewed distribution is that if you have a skew with possible outliers, like say this value down here, it's going to have a very strong impact on the mean. It's going to drag the mean way down, whereas the median is going to be a bit more resistant to that change. So in this particular case, the median is going to be the better choice for the measure of center for this distribution. And to give my explanation, let's talk about the fact that the mean is non-resistant. and I'm going to say non-resistant to skew and outliers. In other words, those outliers on the left, that skew to the left, that's going to draw the mean down quite a bit because it is non-resistant. Whereas the median is much more resistant. So even with that outlier in there, the median is not going to change too much. So because the median is resistant, that's the better choice, and that has to do with the shape of the distribution. So I'm going to say because the distribution is skewed left, we're going to go ahead and use the median as our measure of center here. And you can actually get that right from the summary statistics. The median is 3.9. So we're calling 3.9 the center of the distribution here. And you'll notice if you look at 3.9, it is not the center of the x-axis there, right? It's just what we're calling the center of the distribution of the values, because the median, the middle value, lies within that stack of dots. Okay, let's move to question 3, which is asking for the most appropriate measure of the variability or the spread of the distribution. And we actually have 3 pretty good choices of things that we could use for variability. The simplest would be range. We could also use standard deviation. We could also use IQR. And the answer to which one is most appropriate, once again, has to do with the shape of the distribution. We have a skewed distribution. And the problem with the skewed distribution is that the standard deviation is just like the mean in the fact that it is non-resistant to skew or outliers. What that means is that the outlier is going to have a big effect on the standard deviation, likely increasing the standard deviation quite a bit, right? Increasing that typical distance from the mean. Whereas the IQR, which is actually calculated using the median of the first half of the data and the median of the second half of the data, is much more resistant to change. Less affected by that skew and that outlier there. So almost with the same reasoning as above here, it's based on the shape of the distribution. So we're going to say, because the distribution is skewed left, we're going to use the IQR. Now we should go ahead and actually calculate the IQR here, which is the third quartile minus the first quartile. And if you look up above, we know that, let's see, Q3 is 4, Q1 is 3.7, and that's going to give me an IQR of 0.3. So that leads us into question number 4. Are there any outliers? Well, certainly this 3.1 down here, GPA, looks like an outlier, but we want to actually test that using the outlier rule. So here's what the outlier rule says. If you are looking for an outlier on the low end, which I call a low outlier, which we think we might have here, in order for it to be a low outlier, it has to be less than Q1 minus 1.5 times the IQR. So we're going to have to do a little calculation here. Q1, we know from our summary statistics there, is 3.7 minus 1.5 times the IQR, which we already figured out is 0.3, and that number is 3.25. Now that 3.25 is giving us the cutoff value, and it's saying that anything lower than 3.25 here would be considered an outlier. So sure enough, that GPA of 3.1 is an outlier. Okay, so I'm going to say 3.1 is an outlier here. Now we should check on the other end. I really kind of doubt that there's a high outlier here, but just to go through the motions here and see what the formula looks like. In order for us to have an outlier on the other end, on the high end, it has to be greater than Q3 plus 1.5 IQR. So our Q3 here is 4 plus 1.5 times the IQR is going to give us a value of 4.45. Very clearly, there are no numbers that are greater than 4.45, so we certainly do not have a high outlier. We are left with just the low outlier of 3.1. Now, I'm going to pause right here and make note of something. These 4 questions are highlighting 4 of the most important features when you are describing a distribution, okay? So this idea of describing a distribution, if you're given a free response question that says something like that, you want to make sure that you address all four of the things that you see here. So let's make note of them. In number one, we talked about the shape of the distribution. In number two, we talked about the center of the distribution. In number three, we talked about the variability or the spread of the distribution. And in number four, we tried to see if there were any outliers. So those are the four things you want to make sure that you address when you are asked to describe a distribution. Now, one way that you can remember that, if you look at the first letters of all four of these, and you do a little bit of rearranging here, the acronym to remember is SOX, which stands for shape, outliers, center, and spread. And then I also like to add on the fact that you better include context, because that's very likely going to be part of the rubric on the AP exam. So SOX plus context is the acronym that we use to remember what features we have to describe for a distribution of quantitative data. All right, we're ready to move to the next part now, which says, here is a side-by-side box plot of the results from both samples. Okay, now not only do we have the results for the AP Calculus students, but now we also have the results for the AP Statistics students. And we are now given a box plot instead of a dot plot, along with all of the summary statistics as well. And it sure looks to me like these summary statistics are the same as what we see at the top of the page. But now we have the same values for the AP Statistics students. Okay, so number 5 says compare the distributions. Okay, very important here. We just talked about describing a distribution. You want to talk about exactly the same things when you are asked to compare distributions. So this whole idea of SOX plus context, that's exactly what we need to address here when we are comparing the two distributions. So I'm going to make it very, very clear in my answer here that I'm addressing all four of them. And we're going to start with the shape. Okay, well, we already know about the shape for the AP Calculus students. So let's just state that again. And once again, I'm going to get context out of the way right at the beginning here. The distribution of GPA for AP Calc is, and we said strongly skewed left. But now we need to compare that to the shape of the distribution for AP Statistics. Well, AP Statistics looks to be a bit more symmetric there, right? There's not a big long draw on one side or the other. So I think I'd be comfortable saying fairly symmetric. Now, we don't know exactly what's happening within each one of these quartiles. There could be some peaks and valleys within each one of these quartiles. But sort of generally speaking, this box plot to me is saying fairly symmetric. So I'm going to say, while it is fairly symmetric for AP Stats. So we've definitely compared the two shapes here by noting that they are not exactly the same shapes here. Okay, next thing we want to address, I'm just going to go in the order of SOX here. So outliers would be next. And we've already determined that there is in fact an outlier for AP Calculus. So we're going to say AP Calc has one outlier at 3.1. And based on the box plot here, we don't see any outliers, right? An outlier would be indicated with a little dot or a star of some sort. We don't see any outliers for AP Statistics. So I'm going to say while AP Stats has no outliers. All right, so we've taken care of outliers. Up next is the center. Well, we looked at the center for AP Calc and we decided that we would use the median there. And so the median was 3.9. Well, very clearly the median is lower for AP Statistics. Even if you compare the means, you'll notice that the mean for AP Calculus is higher than AP Statistics. Now, the important thing here is that we are trying to compare the centers, which does not mean that we need to actually list the values of each one. we have to make some sort of comparative statement between the center of AP Calc and the center of AP Stats. And very clearly, the center is higher for AP Calculus students than for AP Statistics students in these samples. So I'm going to say the center of the distribution for AP Calc is greater than the center for AP Stats. Now notice I didn't even have to indicate what measure of center I was using, which would be true whether I was using the mean or the median. I also haven't indicated the exact values of those centers. What's important here is that we've compared the centers. So I'll tell you this part of the solution right here is an important part of the solution. The fact that we're saying that the center is greater for AP Calculus students. All right, for the spread, we're going to have to do the same thing here, compare the spreads. And we could do it using range or IQR or standard deviation. We might choose IQR because the AP Calculus distribution is skewed to the left. But if you look at all measurements of spread, you're going to see the standard deviation is lower for AP Calculus than it is for AP Statistics. If we calculated the IQRs, it would also be lower for AP Calc or the ranges, all three of those measurements. So very clearly here, we can say that the spread for AP Calc is less than the spread for AP Stats. And I'm going to highlight again the fact that the comparative word is the important word here. So definitely when you're asked to compare the distributions, you want to use less than, greater than, similar to. That's the type of language that we want to see when we're comparing those two distributions. All right, and let's get to the last question here, number 6. Do the data provide convincing evidence that AP Calculus students have a higher GPA than AP Statistics students on average? Now, this certainly sounds like something from much, much later in the course, namely a significance test, right? Anytime you see convincing evidence, you think that you might need a significance test to answer that question. But before we talk about convincing evidence, let's just see, first of all, do we have some evidence that AP Calculus students have a higher GPA? Well, if you look up at the data, the average, which I'm going to call X bar, for the calculus students is 3.805. The average for the statistics students is 3.16. So based on these two samples, we can see that the X bar for the calculus students is in fact greater than the X bar for the stats students. So we certainly do have some evidence that AP Calc has a higher average. But do we have convincing evidence? Maybe the fact that these were both just random samples, because of random variability, we just happen to pick some high GPAs for AP Calculus and some lower GPAs for AP Stats. And it's not actually true when we look at all AP Calc and all AP Stats students. Well, in order to answer that question, we need a significance test. So I'm going to say here for the last question, possibly, right? We do have some evidence. In order to know if we have convincing evidence, we would need to do a significance test. And specifically here, let's think about what test we would need here. Well, are we in the world of means, the world of proportions? Hopefully you said the world of means. Do we have one sample or two samples? Definitely have two samples here. So we are going to need a 2 sample, and this is going to be a t-test for the difference of means, mu1 minus mu2, to find out. Now, if you're interested in knowing how to do that particular significance test, we do have a separate video on YouTube that you can check out for significance test for means. All right, so I think that's it for this particular part of the activity, and we are ready for page 2. So if you want to slide on over. And we've got a little bit different context here to start out. All right, so here's what it says. It says, one of the other questions that university admissions officer asked the AP Calculus and AP Statistics students was their college plans for after high school. The table summarizes their responses. Okay, so I notice here in the table that we've got the course listed on the left. We have our two groups, our AP Stats students and our AP Calculus students. And then up here, we are talking about their college plans, which looks like they had three choices. They could say none, or community college, or university here. So the first thing I'd like to do is to identify the variable that's being measured here. And you might say course is a variable because there are two different possibilities there, but we've really like selected samples from two different groups there. And this is really the thing that we're asking though, the sample, right? What are your college plans? So the variable here is going to be college plans. Now let's think just for a second here. Is that variable a quantitative or a categorical variable? Well, college plans has three different categories that they could select there, right? This is most definitely categorical variable. Okay, much different than the first page of the activity where we were dealing with quantitative data, which involved numbers. Instead here, we're talking about categories, the category of none, community college, and university. So let's see what the analysis looks like for a categorical variable, which is going to look a bit different than the analysis we did for a quantitative variable. So here we go. Number one says calculate the percent of AP statistics students for each category of the college plans. Okay, we got three different categories. So let's start with the category of none. And very important here, we're only looking at the AP statistics students in order to calculate this percent. So that means that I'm only looking at these values here, that very first row in the table here. So the percent of AP statistics students that were none, well, that's 2 out of the 10 total, which is 20%. 20% for that first category. Now, the second category is the category of community college. And once again, we are only going to be looking at the first row, which is the AP statistics students. And for community college, I see 3 out of the 10, which is telling me 30% of AP Stat students plan to go to community college. And then the final category here is that of the university. And once again, only looking at the first row, I have 5 out of my 10, which is going to be 50% of AP Statistics students that plan to go to university. So as a quick check here, we can make sure they add up to 100%. And sure enough, 20 plus 30 plus 50 is going to get us there. So we're all good on that. All right, let's move to number 2, which is now to calculate the percent of AP Calculus students for each category of college plans. So now we are only dealing with the AP Calculus students, which is the second row in this table. And we want to find the percent within each category. So starting with none, I have 1 of my AP Calculus students. That is only 1 out of 20. That is 5% of AP Calculus students that do not have college plans. Move over to the next category of community college. Look up in my table here, and it looks like there are 4 out of the 20, which is going to give me 20%. And then finally, the last column we have is the university. And based on the values here, it looks like 15 out of 20. And that is going to give me 75%. So now we're going to try and take those values and make a graph with them. And specifically, we're going to make a segmented bar graph to display the distribution of college plans. So let's start with the AP Statistics students. And we know, let's see here, 20% of those students said none. So I'm going to make a little bar chart here. And I'm going to try and go up as close as I can to about 20%. And I'm trying to stay consistent with my colors here. We have blue to represent none. And then for community college, we have 30%. So I need to stack 30% on top of 20%, which should take me up to 50%. Those are the students that are planning to go to community college. And that last 50% is going to take me all the way to the top here, 100%. is going to be those planning to go to the university. Now that's AP Statistics. Now let's do the same thing for the AP Calculus students. So 5% planning to go or with no college plans, and 20% planning to go to community college. So if I stack 20% on top of this here, it's going to put me at about 25%. So I should be right about here. Doing my best to try and keep this as accurate as possible. And then the remaining 75% plan on going to the university. That should take me right up to the 100%. So there is our segmented bar graph. I will say that you do want to have a key to go along with your segmented bar graph so that the reader knows exactly what each one of those sections represents. And well, we sort of listed it above, but the blue represents no college plans. The red represents community college, and the green represents university. And so there we have a segmented bar graph to show the distribution of the college plans for each one of the groups of students. All right, that leads us to number 4. Is there an association between course and college plans for this sample? Explain. So when we're asking if there's an association, another way of putting that is to say, if we were to know one of the variables